Have you ever looked up at an airplane and wondered how it stays in the air? It's like magic, but it's really science. Today we'll learn how airplanes fly by looking at a popular model, the Cessna 172. The Cessna 172 is a small single-engine plane that many pilots learn to fly in. It's a great example to understand the forces that allow airplanes to soar through the sky. To understand how an airplane flies, we need to understand the four forces that act upon it: lift, thrust, drag, and weight. Imagine these forces like a game of tug-of-war in the air. Lift pushes the airplane up, thrust pushes it forward, drag works against the airplane, holding it back, weight pulls it down towards the ground. Lift is what allows an airplane to overcome gravity and stay airborne. Without lift, an airplane would not be able to take off, fly, or even stay in the sky. It is one of the four fundamental forces of flight, along with thrust, drag, and weight. The wings of an airplane are specially shaped to create lift. This unique design is crucial for the aircraft's ability to fly. They are curved on the top and flatter on the bottom. This curvature is not random, but is meticulously engineered to optimize lift. This shape is called an airfoil. The airfoil design is a result of years of aerodynamic research and development. When air flows over the curved upper surface of the wing, it speeds up, creating an area of low pressure. This phenomenon is explained by Bernoulli's principle, which states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure. At the same time, the air flowing under the wing moves slower, creating an area of high pressure. This difference in pressure is what generates lift. The high pressure underneath the wing pushes up towards the low pressure above it, generating lift. This upward force is what allows the airplane to rise into the sky and stay aloft during flight. Understanding lift is essential for designing efficient and safe aircraft. Section 4. Thrust, the forward force. While lift gets the airplane off the ground, thrust is the force that propels it forward through the air. The Cessna 172, like many airplanes, uses an engine and a propeller to generate thrust. The engine burns fuel to create power, which spins the propeller. The spinning propeller acts like a giant fan, pulling air in from the front and pushing it out the back. This backward push of air creates a forward force on the airplane, propelling it forward. Section 5. Drag and weight, the resisting forces. Now let's talk about the forces that oppose lift and thrust, drag and weight. These forces are crucial in understanding how an airplane maneuvers and maintains stability in the sky. Drag is the force that resists the motion of the airplane through the air. It acts in the opposite direction to the airplane's movement, trying to slow it down. It's like the air pushing back against the airplane as it tries to move forward. Imagine riding a bicycle against a strong wind. That's similar to what an airplane experiences with drag. The shape of the airplane, the smoothness of its surfaces, and even the air density can all affect drag. A sleek, smooth airplane will experience less drag compared to one with a rough surface. Weight, on the other hand, is the force of gravity pulling the airplane down towards the earth. This force is always acting on the airplane, regardless of its motion. The weight of the airplane includes not just the aircraft itself, but also the passengers, cargo, and fuel. Managing this weight is essential for safe flight. Pilots must constantly balance these resisting forces with lift and thrust to ensure a smooth and controlled flight. Understanding drag and weight is fundamental to mastering the principles of aviation. By minimizing drag and efficiently managing weight, airplanes can achieve better performance, fuel efficiency, and safety. This delicate balance is what keeps airplanes soaring through the skies. Section 6. The importance of aerodynamics in aviation. Understanding these four forces, lift, thrust, drag, and weight, and how they interact is crucial in aviation. Lift is the force that allows the airplane to rise off the ground, while thrust propels it forward. Drag is the resistance the airplane faces as it moves through the air, and weight is the force of gravity pulling it down. By manipulating these forces through the design of the airplane and the actions of the pilot, we can make an airplane fly, climb, descend, turn, and land safely. Pilots use their knowledge of aerodynamics to perform complex maneuvers, ensuring the aircraft remains stable and efficient during flight. Aerodynamics is the science that helps us understand these forces and design airplanes that can soar through the sky. Engineers spend countless hours testing and refining designs to optimize performance, reduce fuel consumption, and enhance safety. The shape of the wings, the angle of the tail, and even the materials used all play a part in the aerodynamic efficiency of an aircraft. It's a fascinating field that plays a vital role in making air travel possible. Without a deep understanding of aerodynamics, modern aviation as we know it would not exist. From commercial jets to military fighters, every aircraft relies on these principles to operate effectively and safely.